Hi everybody, I'm Cook, and this is part 5 of the Hydrogen to Human series. In part 1, we looked at how it was completely impossible to describe the universe just using the laws of physics. In reality, we see all this mathematics. That needs an explanation, and this mathematics cannot come out of the laws of physics, which are simple. In part 2, we gave the answer. And the answer was, if I use a combination of physics, which we'll just say is the energy, and the laws of mathematics, I now get a sensible description of the universe as the energy is used up building the structure. I get a complexity gradient. I get the evolution of all the structure. And this is inversely proportional to this. And that shows up in the Boltzmann equation. Now this is a very, very important idea, that the structure in the universe uses this energy, uses it up. And we can see that in chemical weapons. When you release the structure, what's holding it all together? I get a lot of energy out, and even more energy in nuclear weapons. But there's one more kind of energy which is tied up, and that is that matter and antimatter are a conjugate pair, a base pair that start the universe off. Now, we're going to come back to that one. It's a very, very important idea because it gives us the idea that the universe is cyclic. It's a repeating process, a continuum, which is taking place all the time. But let's just go back to my little computational universe. The idea that the universe is a computer is more than 100 years old. Boltzmann's equation shows that energy, just energy by itself, is inversely proportional to information down here. And the information always starts as pairs, conjugate pairs, a term that Niels Bohr brought in as complementarity. Nothing exists as a singularity. A singularity is dead. A black hole is a relationship between different parts of energy. Concentrated energy, which is being concentrated by distortion in space, which is being distorted by the concentration of energy. I've got two parts which distort each other. So a black hole is when space turns into a sphere. And there's a very, very different ratio in the levels of energy for space and matter, and it's that ratio which determines how much energy I need concentrated in the middle of a black hole before space turns into a sphere. So my relationship between energy and mathematics describes what I see. Now, if the universe is a computer, computers need an algorithm. Now let me just explain what an algorithm is and why it's different from a recipe or just a set of instructions. An algorithm means you have to go back to the beginning and start again. Now Brian Cox has already stated that there seems to be a magnificent simplicity that builds the elements. And that seems to drive the universe. Well, let's reveal that simplicity, that computer, that algorithm. If I go right down to the base here, I just find conjugate pairs. Everything is two manifestations of the same thing. The two different kinds of quarks, up and down. And the up quark can change into a down quark. So they're two manifestations of the same thing. The two leptons, which actually facilitate that change. So there's a relationship between the leptons and the quarks, and space and matter. Now space itself can just bubble into matter and antimatter, and then bubble back out again. We see that in the Casimir effect, and that means that space and matter are two manifestations of the same thing. It's binary down here. I get binary pairs. But when I want to start computing and constructing the first new unit in the universe, I want to compose something, I find I need 3 parts. And there's a relationship between the binary part of the computer and the complex triple part. When I compose a proton, I need 2 quarks which must have other aspects which are different. That's why the quarks come in the colours. We say the colour forces. So electromagnetic forces, quantum electrodynamics, the colour forces, quantum chromodynamics. And I must have a difference between the two to satisfy Pauline's exclusion principle, which doesn't allow me to have 2 entities in the same state. And it's that rule which builds the structure of atoms. So I'm going to use my rule here, 2 up quarks and a down quark. Now, if I want to change my proton into a neutron, I've got to use the 2 leptons which come out of here, but they're not in here. So there's a very, very strong relationship between what's in between the 2 leptons and what happens to the 2 quarks. It changes one into another. I've now got a neutron built from 2 down quarks and 1 up quark. And now I use my same algorithm again to build the atom. I've now got the proton and the neutron, my binary pair, and I add to it the electron. I get the atom. Now this doesn't stop with just building the elements. We see it everywhere. If I go right down to the colour forces and the forces which are, the electromagnetic forces which are building that proton, that comes in thirds. And I get 1 part, I get plus 2/3, plus 2/3, minus 1/3, and it all adds up. Then I get the neutron, minus 1/3, minus 1/3, plus 2/3. Now this little pattern, this little algorithm, I see it everywhere. I see it in the 2 correct rows of the standard model, which build the 3 generations of matter. Now this is seen as a bit of a problem, but if I see it as a universal pattern, which builds the standard model, the elements, the 3 pairs of forces. Now previously we said the 4 forces, so it's in the wrong pattern and I can't see what I'm doing. But the 3 forces, gravity, a relationship between a pair, 2 parts of energy, the fields and the matter. This is the weak relationship. There's also a strong relationship, general relativity, and all the rest of the forces are also just relativity, in the same pattern. We've missed it. So I've got gravity, a relationship between a pair. Then I've got the electromagnetic forces, electromagnetic, another pair. Then I've got the strong and weak forces, another pair. So once I put them in the same pattern as the 2 correct rows of the standard model, I start to see that my algorithm just appears everywhere, all around me. Sines, cosines and tangents, real numbers, imaginary numbers, complex numbers, dimensions. I get 2 dimensions with no volume, and a third one suddenly brings volume. But I wasn't the first person to see this. That was Pythagoras. I'm just going to read to you from a very good book written by Frank Close on particle physics. Now what he's talking about is the 3 generations of matter and the relationships between the top and bottom quarks. As a result, it is now clear that there are small but definite deviations from that apparent universality. The 1 part in 25 is a real deviation, and there are others that show up when measurements are even more precise. Remarkably, all of these turn out to be linked together in a way that we can illustrate using nothing more sophisticated than the geometry of right-angled triangles and Pythagoras' theorem, and reveal that there is indeed a profound universality at work. So it was the Greeks who first found the algorithm of the computer. They also found the binary parts, that numbers came in rational, irrational, the finite and the infinite, the infinitesimal. Then numbers like pi and e, which are transcendental and irrational. So I see this profound universality building up complexity in the universe. The 3 fundamental forces, a relationship again in the same pattern, 2 pairs of atomic forces acting against 1 pair, distortions in space and matter that we call gravity. And that gravity is coming from the mass here, so it's a feedback loop. This works at the individual level. This works at the collective level. Another conjugate pair. This and this act against each other to build planets. This, gravity, and the nuclear forces act against each other to build stars, and the atomic forces act against each other to build atomic nuclei. I need both pairs of forces to build the nuclei, and I get ratios in between which build the energy levels, which hold the electrons at the right numbers. Numbers 1 and 2 and 3, I'm quantifying exactly what numbers are. Whole numbers. The elements come in whole numbers. The energy level of the orbits come in whole numbers. And Marcus de Sauter has already seen this relationship here and the patterns that show up in mathematics in the zeros on the line of Riemann's hypothesis. So we know it all fits together. We know it all fits together. We can see it. And my computer builds into ever more complexity. My binary parts, relationships between stars and atomic nuclei. Stars are very simple compared to planets. They don't have chemistry. Just the atomic nuclei, very simple compared to atoms, which have complexity and need another set of mathematics based on prime number theorem. So here I get simplicities, I get mathematical patterns at the gravitational level and the atomic level. These are the biggest patterns. They're very, very simple. They're not like solar systems, which have very, very complex behaviour and feedback loops. This behaves as a whole unit, this behaves as a whole unit between what's happening in the middle and what's happening on the outside. And it's not coincidence that we see the same patterns. The biggest atomic pattern, the biggest gravitational pattern. And then I flip over into my very, very complex parts of reality, my dualities, my binary parts, and then my complex parts. The complex parts which are described by the mathematics of non-linear dynamics. And what happens here is that the same physical components here, my binary parts, the Earth and the Moon, which behave to Newtonian mathematics, flip over into complex mathematics, first shown to us by Poincaré. Now we've had this problem, Newton found this problem. Well, here's the solution. If I now just show that the simple parts of physics and mathematics are here, the complex parts are here, if I just put those two together, I get a reality which is the same as I am saying. Something which I can see, something which I can say are the same. And that universality goes on and shows up again and again and again in life. So let's show you a very, very complex example of this little algorithm here. Now life is all based upon glucose, the energy. I've got to pump energy in to go against entropy. I've got to use energy and take this and put it in here to build structure. That's the way the computer works. So if I look at photosynthesis and respiration, I see there are two manifestations of the same relationship. Now we've been looking at this for a long, long time, thinking, isn't that strange? It all just matches up. Respiration, what animals do to the glucose, goes exactly back into the base components, which come in this relationship between two parts and one by itself. And I need three pairs. Two parts, one by itself. Two parts, one by itself. Now I'm beginning to see, and I get here, three pairs, the same pattern. And there's no way that all this is happening by coincidence. Now once you've seen the pattern, you can go on to put it all in a table like this. And we keep building all the parts that make the elements, the simple parts, and then we build elements and stars, and then we go on to build all the complex parts. And even the dimensions flip over and bifurcate. I get bifurcations that produce my conjugate base pairs, separate energy into space and matter, and they act against each other. And we call gravity negative entropy. That has to stop. It's positive self-assembly, concentrating the energy into holding parts together, into composing structure. So there's a completely new model of the universe. The computational universe. Something that now anybody can look at. You don't need to be a specialist to look at the pattern and ask yourself the question, is it always the same pattern, or is it not? It's just logic. So in the next part of the series, I'm going to show you how we can now build a new standard model and put all the parts which are just stuck on the end ad hoc into the same pattern as the quarks and leptons. And we can put in all these different parts of mathematics, three different pairs of forces, and the whole universe. Bye bye for now. See you next time.